Hello, this is Muhammad Sajjad. In this video, we are going to discuss about two topics. The first one is ionization energy and the second one is electron affinity. So firstly, we are going to discuss about the ionization energy. Let's talk about the definition. In terms of definition, ionization energy is the amount of energy required to remove the most loosely bound electron from the valence shell of isolated gaseous atom. So if we notice on definition, we are going to discuss about three factors. Firstly, it is energy required. First thing. Second, electron should be loosely bonded, which means it should be in the valence shell. And the third one is the atom should be in gaseous state, like it should be isolated, which means it shouldn't be bonded with any other atom, like it shouldn't be a compound, it should be an isolated atom like in the gaseous state. So this is the definition of ionization energy. But the ionization energy increases when we are going to remove another electron. After removing one electron, if we want to remove successive electron like another electron, the ionization energy will be increasing. So let's talk about the types of ionization energies. Mostly we are going to discuss three types of ionization energies. First ionization energy, second ionization energy, and third ionization energy. So as per the name refers, first ionization energy, which means we are going to remove one electron, like the first electron, from the valence shell. Okay, so in terms of second ionization energy, which means we are going to remove second electron from the valence shell. This is called second ionization energy. And in terms of third ionization energy, after removing two electrons, we are going to remove any other electron like a third electron. So the energy required to remove the third electron from the valence shells is called third ionization energy. And again, it should be a gaseous atom, like in the isolated form. It shouldn't be a compound like water, it shouldn't be a NaCl. So these are compounds, so it should be like, if we talk about the example like sodium, so sodium should be in gaseous state, like it should be an individual atom. So if we want to remove first electron from sodium, the energy required to remove an electron from the sodium gaseous atom should be 496 kilojoule per mole. So kilojoule per mole is the energy, unit of energy. So kilojoule is the unit of energy and per mole is for the element from which we are going to remove the electron. So per mole, we all know that the per mole of any substance contains 6.022 multiplied 10 to raise 23 atoms. So this is mole. Okay, so to remove the electron from 1 mole of sodium atom in form of gaseous state, so the energy will be required 496 kilojoule per mole. Okay, so if we need to remove another electron from the sodium in state of gaseous atom, so energy will be increased when we remove the second electron. It would be around 7 to 800, and the next third one should be around 1400. So you can imagine energy will be increasing when we remove second and third electron, because the second and the third electrons will be tightly bonded with the nucleus. Like it should have the more strongest bonding with the nucleus and the electron. So that's why it will be difficult to remove the second and the third electron. So when we talk about the trend in period and group, so ionization energy in period will be increasing when we move from left to right side in the periodic table. Okay, so why it will be increasing? For the electron to remove from the valence shell when we move from left to right in the periodic table. So if we talk about the example, if we talk about the second period from lithium to neon, so let's talk about this period. So ionization energy will be low in terms of lithium, as we are talking about the first element in the group, in the period. So for lithium, the ionization energy will be 520 kilojoule per mole. So if we move further for beryllium, like Be, the ionization energy will be increasing like 899. So for the third element, which is boron, the ionization energy will be 801. This is low energy as compared to beryllium. So we are going to discuss this exception later on. Firstly, we need to discuss about the normal behavior of the elements in the period. So for carbon, it would be 1086 kilojoule per mole, and for nitrogen it would be 14, like it's increasing when we are moving from left to right in the period. So for oxygen it would be 1314 kilojoule per mole, and it would be 1681 kilojoule per mole, and for neon it would be 2081 kilojoule per mole. So let's talk about the exception in this period. So when we are discussing about the half filled shells, or when we are going to discuss about the S shell, the energy will be higher, like more energy will be required to remove the electrons from S orbital or from half filled orbital. So if we talk about the exception, only two exceptions can be seen in the period. So in period 2, so from period 2, in period 2, and the group will be 2 to 3, like in 2 to 3. So if we talk about the beryllium, it's belong to period 2, and the group is also 2. Okay, and if we talk about the other group like boron, it belongs to period 2, but it's also belongs to group 3. Okay, so this is the point of exception as we mentioned before. So for beryllium it's 899, and for boron it's 801. Okay, the energy decreases. Why? Because in case of beryllium, we are going to remove the valence electron from s orbital. So its valence electron is 2s2. So it's difficult, as I aforementioned, the electrons will be difficult to remove from the s subshell. So if we talk about the boron, the electrons, the valence electron is in 2p1, like it's 2p orbital, and the only is one electron in the p orbital. So it's easy to remove the electrons from p orbital. So p orbital is also greater in size as compared to s. So as the size of the subshell increases, energy will be less, and if the if we talk about the S subshell, it's round in shape and it's the first shell, like after 1s it's the first subshell. But in terms of valence subshell, it's the first one, so it's difficult to remove electron from 2s as compared to 2p. So if we talk about the trend in group, the energy will be decreasing from top to bottom in the group as the number of shells are increasing and the shielding effect is also decreasing. When the shielding effect decreasing, it means energy will be less required. It means the to remove the valence electron from the valence electron from any element, it will require less energy from top to bottom in the group. So this is what about ionization energy in period and in group, and we saw the trend. So this is all about the behavior of elements in the group and in the period, and we talk about the definitions, we talk about the trend, we talk about the examples. So